Lab 1. So the purpose of this lab was to determine the excess charge in one piece of charged tape. The useful formulas are the two versions of Coulomb's law we use, Newton's second law, and the charge on an electron, which is the negative inverse of this. And the results were that the tape had a charge of 4.447 e to the negative 9 coulombs with an electron deficit of 2.779 e to the 10th. So for the experiment where we levitated tape, the items I used were 2 plastic food containers and 2 pieces of charged tape. The system was tape B, the surroundings were tape A and earth. The initial conditions were that tape B hung loosely between both food containers. The length of each tape piece was 28.37 centimeters, or assumed to be for mathematical calculations, which meant that the mass of each tape piece was 0.2837 grams. The distance between the tape pieces when tape piece B started levitating was 0.8 centimeters, and the magnitude of the gravitational force had to equal the magnitude of the electric force on tape B, which was 0.00278 newtons. And the main assumptions used were that the tape pieces were identical and had identical charges evenly spread across their surface, and that the charge of the tape pieces could be condensed to a point. So, continuing on, the calculated data from the experiment, force of gravity had to equal the force of the electric field on tape B, which meant the charge of tape B was 4.447 times 10 to the negative 9th coulombs. The electron deficit of tape B was 2.779 times 10 to the 10th electrons. The number of atoms on the sticky surface of the tape was 7 times 10 to the 17th. The ratio of the electron deficit to the number of atoms on the sticky surface was about 3.9 times 10 to the negative 8th. And the observations from the lab were that 2 U-tapes repelled if hung close together. The interacting fields of the tape caused them to wobble. The U-tape attracted to neutral objects, and from the pin test we know that U-tape is positively charged because it attracted to the pin. So for the coding, we created this little model over here, which shows that the electric field force on tape B equaled the gravitational force on it. And we got that by defining the E-force equation over here, the gravitational force over here. We took both tape A and tape B and condensed them into points. That's tape B and A here. And then these are the main values that we used in the calculations. So for the error sources, the assumptions caused plenty of error. The tape piece wasn't Scotch tape either. It was something else that was a little heavier. So there's error in that. And then imprecise measurements of distance between the two tapes when tape B starts levitating. So for what if, not many of the observations would change if electrons had positive charges and protons had negative charges. Like charges would still repel, opposites still attract, charged objects attract neutral ones. The same observations could have been made with negatively charged L tape instead of positively charged U tape, which led me to the prior conclusion about if protons and electrons charges were switched. And for Y, the more a charged object touches a neutral object, the more of its charge would pass the neutral object. My hand progressively became charged as I was making U-tapes, so the more we make contact with the tape, the more charge it would pass off. Charge like pressure seeks equilibrium.